Here, we will know the confidence intervals. Confidence interval is a range of the values that contain the population parameter, for example, the population mean, with a specified amount of confidence, for example, the 95%. For example, right now you have a sample, and you know the sample mean. Based on the sample mean, you want to make inference for the population mean. So here, that's why we use the confidence level. Based on the information you have for the sample, you want to make some estimates for the population mean. And how do we estimate the interval? The idea for the confidence interval estimation is that the sample mean is within the certain distance from the population mean, and also the population mean is in the same distance from the sample mean. For example, right now you have the population, you know the population mean, you generate sample from the population, and you get a population. You generate a sample from the population, and you get a sample mean. You want to know what's the possibility that the sample mean in a certain interval away from the population, which means what's the probability that a sample mean will located in a certain confidence interval. But here we don't know the population, we don't know the population mean. We only know the sample mean, and we assume that the population mean is within the same distance from the sample mean. So which means we can use the sample mean to make inference for the population mean. As we discussed before, that the sample mean can be used to calculate the t-score, which is in the t-distribution. With the t-score, we can find the percentage of the observation lies below or above the sample mean. So we can find an interval which the range of the observation lies below or above the sample mean. Here we can set 95% the confidence interval for the population mean, and so we have to find the interval such as the percentage of the observation that lies below and above the sample mean is equal to the 95%. First, let's take a look at confidence interval with the 95%. For this one, you can see the sample mean is in the center of the interval. So we standardize the value into t-score. T-score means the standard errors. This part is the t percentile multiple the standard error. This is the standard error for the sample. And here, for the t2.5, it is the percentile of the 2.5. So we have 2.5% of the observations in the t-distribution lies below this value. T-distribution, the 2.5 is a negative value. So when we add this part, because the standard error will be the positive value. So after we multiply them and add this value to the sample mean, we subtract some value from the sample mean. For this part, the T97.5, then we have 2.5% of observations in the t-distribution lies above this value. 97.5 percentile t-distribution is a positive value. When we add this part to the sample mean, so we increase the value. This confidence interval gives us the interval that excludes the value which is very extreme, and the interval includes the 95% of observations lie below and above the sample mean. This means This interval contains the population mean with probability 95%. And here we can also get the confidence interval with a 99%. So here with a higher percentage, which means we try to exclude those most extreme value here. We exclude the extreme value with 1% probability happening. So you can see we switch T2.5 percentile to T0.5 percentile, and we switch T97.5 to T99.5 percentile. So this interval includes 99% of all the observations lies below and above the sample mean, which means this interval contains the population mean with probability 99%. Let's take a look at the example. Suppose you have a sample with 20 observations, and you know the sample mean is 17, and you know the standard deviation is 3. And you want to find that interval of values such as with 95% of probability, the population mean lies within the interval. We use the formula we discussed in the last slides. We already know the sample mean is equal to the 17, and we try to get a value for the T2.5 percentile and multiple the standard error. In this sample, we have 20 observations, so we can get T2.5, the percentile satisfy the t-distribution with 19 degrees of freedom. We get the standard errors. The standard error can be calculated as the standard deviation divided by the square root of the number of the observations. It's equal to the 0.67. Then we can use the statistical calculator. So we try to find the 2.5 percentile of the t-distribution with a 19 degree of freedom. 2.5 percentile, the value equal to the minus 2.093. 97.5 percentile, the value equal to 2.093. So then we can calculate the 95% confidence level. So we get the value between multiple the T2.5 percentile with the standard error and the plus the sample mean. Then we get the T97.5 percentile multiple the standard error and plus the sample mean. So finally, we get a confidence interval from the 15.6 to 18.4. So therefore, with 95% of probability, the population mean will lie between the two values